Okay, so here is the definition of a composition of functions. So a composition of functions, you often see the word input and output. So it's kind of like a machine. So you are going to take a value for x, and that is your input. And then you're going to plug it into an equation or a function, and then you get an output. So that output is generally y. And then that output then becomes an input for the next function. Okay, so then it becomes x for the next function, and it gets subbed into the other function. So you're going to see something that looks like this. So you will see an open circle. So this open circle means composition. Right? It's not to be confused with multiplication. Okay. I can also write this as this, and we read that as f of g of x. Okay, so f of g of x. So that is an indication of composition. So what that means is I'm going to take a value for x, I'm going to sub it into g of x. So we always do the inside function first. So I'm going to take a value for x, I'm going to sub it into g of x, and that's going to give me a number, and then that number is then going to go into f of x, the outside function, to give me my final answer. Okay, so x is the input, produces an output, and then I will get a final result. So here I have the inside function g of x, and then I have the outside function f of x. So I'm going to take x, I'm going to plug it into g of x, which is going to give me a value, y, and then that gets plugged into f of x and gives me my final result. Okay, so that's why we always talk about, sometimes they compare it to a machine or an input-output machine. And we are going to look at, so remember I told you that there were 3 different ways we can represent functions. We can do table of values or ordered pairs. We can then plot them onto a graph. So we could have a graph of a function, or we could have equations of functions. Okay, so for example, let's say I have these 2 sets of ordered pairs. So they're just organized into a table. So I have f of x is the top table, and then g of x is the bottom table. So let's say I were composing, let's do g of f of x first. So I'm going to compose g of f of x. So we're going to start with the set f of x. Okay. So we're going to start with the first x value, which is -3. And the output is 8. So that output then becomes the input for g of x. So I'm going to look along all the x's in g of x, and I'm going to look for the 8, and then that produces a final result of 2. So the link is the 8. So the point would start with -3, the output is 8, which becomes the input for the next function, g of x, and then final result is 2. So the ordered pair would be starting with -3, I ended up with 2. Then I go to the next point. So the next point is -2, 6. So I'm looking for a 6 in the x values of g of x, and I don't see a 6. So I'm not going to use that point. So the output does not match an input in the next function, so we can't use it. Then we go to the next point, 0, 3. Well, I see a 3 here, so I can use that point there. So starting with 0, 3 output becomes 3 input in the next one. Final result is 5. Then I go to the next point, 1, 2. Is there a 2? Yes, there is right here. Okay, so there's a 2 over here. So starting with 1, linking up with the 2, final answer is 3. And then I go to the next point, 4, 5. Is there a 5? Yes, there is right here. So starting with 4, output is 5, which becomes the input. Final answer is 4. Then I go to the next point, 5. Output is 8, which becomes the input. The final answer is 2. And I go to the next point, 8. Output is 11. I see an 11 here. Final result is -2. And then the next point is 15. So starting with 10, output is 15, which becomes the input here. Final answer is -5. And then the last point ends in a 20. I don't see a 20, so we're not going to use that point. Okay, so I can only compose ordered pairs that have an output matching to the input in the next function. If there is no matching x value, you can't use it. Now, keep in mind that it's different if I go the other way. So if I wanted to do f of g of x, I'm going to start with the function g of x and work towards f of x. So starting with the first point is 0. Output is 1. Looking for a 1. There it is. Output is 2. So there's my first point, starting with 0, ending in 2. The next point is 2, 3. I don't see a 3. Can't use that. The next point is 3, 5. I see a 5. So starting with 3, ending in 8. 4, 10. I see a 10. So starting with 4, ending in 15. 5, 4. I see a 4. So starting with 5, ending in 5. 8, 2. Don't see a 2, so can't use that. 9, 0. I see a 0 here. So starting with 9, ending in 3. 11, -2. I see a -2 here. So starting with 11, ending in 6. And then 15, -5. I don't see a -5, so we can't use that point. Okay, so again, we're only using the points that have that link between the output of one becoming the input of the other. Okay, so that's ordered pairs or tables of value. If we have a graph, we just read it off the graph. We don't have to know the equations of these lines. So don't worry about finding an equation given a picture, okay? All you have to do is read it off the graph. So it wants us to find g of f of 4. So f is f of x is this line. This is f of x. It might be hard to see there. And then g of x is this line. So we do the inside function first. So the first thing we want to find the value of is f of 4. So we're going to go along the line f of x. We're going to go across to 4. Go 1, 2, 3, 4, and down here the value is -2. Then that output becomes the input for the next function, which is g of x. So now I want to find g of -2. So I'm going to go along to -2. I'm going to go down to the green line, 1, 2, 3, 4. That value is -4. So g of f of 4 is -4, right? So input 4 into f of x, output is -2. Input would be -2 into g of x, final output is -4. If I wanted to go the other way, let's say I wanted to do f of g of 1. Okay, so we do the inside function first, g of 1. So we're going to go to the graph. G of 1 looks like it's 2. And then that goes into the next function f. So I'm looking for f of 2. and f of 2 is here at -1. Okay, so if you have a graph, you just read it off the picture and sub it into the next function. If you have equations, same thing. You're going to do the inside function first, and then take that output and sub it into the input into the next function. So the first thing I have to do here is f of 3. So f of 3, f of x is given as -12x squared plus 5. So I'm going to put in 3 into this function to get my output. So that output is -103. And then that output becomes the input for the next function, which is g of x. And that's going to go into the equation for x plus 1. Okay, so I just multiply, what's that, -412 plus 1 is -411. So equations, ordered pairs, graphs, and equations, it's the same process. Do the inside one first, and then that goes into the outside function. Okay, let's see if we have an equation. So these are just values. So let's say in this one, f of x is given as 3x minus 5, g of x as x squared. It wants you to find f of g of 3. And then it wants you to find the other way, g of f of 3. And just to show you that we're not going to get the same result, right? Order matters. So first I'm going to do g of 3. And that function is x squared, so that would be 9, and then I'm going to do f of 9, and that is 3x minus 5. 3 9s are 27, minus 5 is 22. Okay, which will give me a different result if I go the other way. So f of 3 is 3 times 3 minus 5, so that's 4, and then it becomes g of 4 is 16. So we see we get two different results. Even though we're using 3, we're just going in a different order, different direction, and we get a different result. We can put it into its own function. So it wants to do f of -2. Right? It doesn't have to go into a different function. It could go back into itself. Let's write this out. So it's f of -2. So I'll do f of -2 into the function -9x minus 9. So what's that? 18 minus 9 is 9. And then I'll do the same function, but this time with 9. So what do we get? -81 minus 9 is -90. So it doesn't have to be two different functions. You can substitute it back into the original function. These are just similar questions, except we have a square root. I don't think that really makes much difference. Let's do f of g of x. Oh, f of g of 12. Let's do that one. F of g of 12. So we're going to do g of 12 first. So x minus 8 becomes 12 minus 8, which is 4, which gives me a value of 2, and then we'll do f of 2. So 2, so that gives us -8 plus 2 is -6. So you're going to get a variety of different equations. These ones are just repeating. We might have 3 functions. So here we have f of x, g of x, h of x, and it wants us to find h of g of f of 2. So h of g of f of 2. So we start with the inside function, which is f. So we're going to do the 2 first. F of x is given as minus 2x plus 1. So we'll sub that in. Then that output becomes the input for the next function, which is g. So we'll do g of negative 3. Make sure when you sub it in, you put it in brackets, especially because this is squared. So we want to make sure that we get the signs correct. Right, so negative 3 squared is 9, not negative 9. And that gives me root 4, which gives me 2. And then that output becomes the next input, which is h of x, and that is given as 5x. So 10. Okay, so there might be more than one function. There might be 3. Then it wants me to find f of 4 times h of 3. So no different. I'm going to do the inside first. I'm going to do h of 3. So 5x becomes 15. Then it wants me to multiply that by 4. So 4 times h of 3. Oh, not f, h. 4 times h of 3. So that would be 4 times 15 is 60. And then it wants me to do f of 60. So the rules still apply. You want to do the inside out, right? Always the inside first, and then work your way towards the outside. Okay. Let's see. So these ones are just repeating with different equations and different values. What time is it? Okay, we'll just do one more thing. So what if it's just an equation? Just let me pull this up here.